Welcome and thank you for coming to our webinar. Yesterday we have released a new version, so now we would like to introduce you what is coming in IDEA StatiCa Steel 9.1. We are using GoToWebinar and you are all in a listen-only mode, so please feel free to input your questions into a question window and we will answer them immediately into the chat or at the end of this webinar. My name is Martin Rolny, and I have my colleague Vít here today. And we will show you new features and improvements in IDEA StatiCa Connection, BIM, IDEA Connection Lite, and Viewer. So, Vít, what is coming in IDEA StatiCa Connection 9.1?
Thank you, Martin. Let's jump right into the presentation. But first, we have to do a little roll back in time to see and to create some intro to new stuff. So let's go back a little bit and let's talk about in 3 minutes about Connection 9.0. In the previous versions, we implemented new stuff, for example, new solver, new methods, manufacturing operations, etc. And the version 9 was game changer in the user interface. We want to create a better new application with pressure on effectivity and time efficiency. We implemented a new templates for quick design, for design of the whole connection, to learn how to design and to help you with the start of the project. We also implemented a single object templates, which will help you to connect one member to another. And all this stuff is available in the 3D window under the right mouse button click. So now we can do a lot of things in 3D window just only with the mouse. All these things helps to improve efficiency, and we take another step further in this topic because we want to create better application. So the Connection 9.1, the main improvements are the parametric templates. The one object templates are now parametric and they can adapt to various cross sections. They can stretch, replace the bolts, adjust the thickness of the plates, for example, which is quite nice feature. We also implemented another auto checks of model warning. This is overload check, and it will prevent you from calculating the connection if the load is higher than third member capacity in axial loading, shear loading, and bending. And this is one of my favorite, boundary conditional conformity. It's a warning that gives you a hint if is set it some untypical model type. For example, if you remove 3 degrees of freedom on member, and then you restricted the reaction, and you will get probably some additional secondary forces on the model, which is really unrecommended way how to create a model. And now the application will tell you the load in every restricted reaction. And I prepared for you a practical demonstration of these features. So let's jump right into the application. we will start from the blank project. So let's begin with the parametric templates. I will start with this one. And let's say I want to connect the horizontal member, horizontal beam, with the column. Oh, with this template. I really like it. Okay. So far it's nice. But when I want to change the cross-section of the horizontal beam, for example, I will use IPA 500, which is quite huge. Now it's not so nice. Okay, so I can do it manually, but I'm too lazy for that. So I will connect it again by this template and see the result. Great, it stretches all over the height of the web of the horizontal member, which is great. So now we have 6 bolts. But I'm not still satisfied. I think the bolts are too small for this kind of huge beam. So let's do it again. I will just click again and I will change, for example, for 20. Great, so now I have 5 bolts and it looks far more better. So this is one example. Let's proceed to another one. And I will choose a pipes. Let's change it for another cross section. For example, bigger one. I really like this one. So let's apply the template. This first one, it can be. That's nice. But what if I want to change this cross section? I don't want to change it manually. So again, let's apply the template. And now it looks far more better. So the template adjusted itself the dimensions to react to the change of the cross section. And the third example as the last one. Okay, we will connect it. I like this one. It's a quite nice connection, don't you think? But sometimes we have to change the cross sections to increase the bearing capacity, for example. So let's change it. This one. And it's not good. And I'm too lazy to do it manually. So again, let's connect it. Great. And sorry, I forget this one. So again, and now the fin plate is not stretched to the whole height of the cross section, which is not good for me. So I have to do it again. Great, I'm satisfied. Now it's all great. What do you think about it? Do you think it will make your work more efficient? We hope so. And let's demonstrate the auto checks. I will continue on. For example, this template. Yes, sure. The first one, the overload control check, it's easy. Let's input here, for example, 400 kilonewton meters in bending around the y-axis. It's too much? Yes. In older versions, you will spend maybe 10 minutes with calculating of nonsense. And now you have here a stop. Analysis connected member is overloaded. Member B. Okay. So let's adjust the loading in a better way. Great. We can calculate it right now. That's one, and the another with the boundary condition. Well, at the start we have to fine-tune the connection or the joint little bit. So just give me a second. I will copy the member, place it in the right position, and cut it. Great. And now let me add another model type to the beams. Right now I have a restriction. 3 degrees of freedom was removed to the end of both horizontal beams. And let's add a load. Sorry, I will turn on the equilibrium and let's add the load. I will use import from Microsoft Excel spreadsheet. So that's it. Let's replace the existing loads and we are fine. Now we can calculate it. And you can see from this point of view that this joint is quite nice. It's a typical one. And the question is, what do we get? What do we get as an info from application? Here in the check and analysis, we have a non-conformity warning or information. So here we have in Y, Rx and Rz some internal forces which are calculated in analysis 2 because it's some kind of secondary forces. It's due to restrictions of our degrees of freedom. So engineers have to be warned about this and have to be aware of this. Okay, that is the finish of our practical demonstration. Let's jump back into the presentation. Another new feature is implementation of stiffness analysis in torsion. Now the IDEA StatiCa connection can calculate dependency of the torsional rotation on torque moment, and it will give you some necessary information. Another one, a lot of people asked about this. We changed the position of the result palette from the separate window to the 3D scene, which improves the readability and it improves the way how we can control the results. Another thing, now you can save your settings, your code settings. For example, you will change the material safety factors to your desired values, and you can save it as a default for all your projects. If you start again from a blank project, you will have your previously saved values. And if you're not satisfied with it, you can reset it to original ones. Oh, sorry about that. We also implemented an Australian code. We implemented all materials and cross sections like universal columns, universal beams. We implemented all formulas for all checks due to the Australian code, and we offer all checks in the result tables. And now it's a turn for my colleague Martin. Martin, it's your time now.
Okay. Perfect. So let's move on and check the latest improvements in IDEA StatiCa Beam. So first, we have a redesigned code check manager to provide you an easy work with more connections, quite nice and brief overview of results, and also effective data synchronization between projects. As I already mentioned, we have prepared a new overview window with a preview of all joins and connections. We can easily highlight the designed joint in the original find element or cat model in the original application. And we have, let's say, put all projects on the same location to the original project of where we are imported the connections. We also prepared, let's say, new commands to simplify the workflow, so we can easily synchronize the projects. We can calculate all or recalculate all projects just by one button. And for the CAT applications, we can modify the imported connections, or let's say the update the exported connection. As we talk about the synchronization, we can easily read from the find element applications the cross sections and load effects, and from the CAT applications the cross sections and objects like welds, bolts, plates, and so on. And once you import your connection into IDEA StatiCa connection, you don't need to define again the manufacturing operations in from the find element applications and the load effects from CAT applications. What we have also prepared, it's quite nice new feature, the synchronization of the load effects between the IDEA StatiCa projects. So once you create the connection from the FEM application, you can just easily import the load effects into another project which was created from CAT application. And how does it work? I would like to show you in a practical demonstration. So for that, I will just prepare one model which is created in advanced steel and also in SAP 2000. As you see, that's just one structure, some quite easy steel frame. When we have in SAP just loaded, we define all combinations and so on. We can of course check the profiles, and when we need to design our connection, we can just easily start our plugin, select the members which I want to design, and I can create a new connection in IDEA StatiCa. As you see, I can select from supported codes. In our case, I will use the Eurocode, and I will just click button new. And now you see in the progress bar, the project is importing from SAP 2000. Okay. Let me check, just okay. And as you see, we have a wizard which was already reading the data from SAP 2000. We have the profiles and the members. Also, the bearing was already set, and we can check what is coming from SAP 2000. So here we have some load cases, the combinations which were already defined in a SAP. Yeah, so we can check them, maybe if necessary, of course, modify them. And when it's okay, I will just click to connection design button, and the project in IDEA StatiCa connection is automatically created. Okay, so now we just need to wait a while for the IDEA StatiCa connection, and as you see, here are my profiles and members, of course, with the load. Yeah, so here we have two combinations with internal forces on the members, and that's it. Yeah, and now we would like to design and check this connection. I'm also a little bit lazy, as mentioned Viet, so I will use the advanced steel model. So now I will just close this project. Yeah, this project is now saved here. I can see it also in IDEA StatiCa Code Check Manager, and I will jump to advanced steel. So let's do this, and I here already have a design of this connection, but of course without internal forces because it's a CAD application. But I can also read this connection and import it into IDEA StatiCa. So let's start our Code Check Manager from advanced steel, and I will create this connection from advanced steel. So let's select a node, just this one, perfect, connected to members, okay, and the connection. Yeah, now we are importing the connection from the advanced steel. We just need to again wait a while for the IDEA StatiCa connection, perfect, it's here. And as you see, I have my connections, of course, again with the members, but as you see, I'm missing the load effects. So what we can do with that, just to use one button, import load, and I will now select my project, which was exported from SAP 2000. Okay. And now you see that I am just imported the loads or the internal forces which are coming from SAP. Perfect. So let's check it whether it works or not. I will just start the calculation button. Okay. There are two combinations. So to analysis, yeah, and I have checked the connection, and I see that my bolts are not satisfied to check here. So what we can do now, I will close this project and I will update my design of this connection. So for that, let's go back into the advanced steel, select the connection. Maybe I can check the thickness of the end plate. So let's go here, maybe just to be sure, for 18 millimeters. And I will also change the bolt. So let's use 16. I hope that it will be good enough. We will see. Okay, update. And let's close it. And if I start my Code Check Manager again, then you see that I have here my project, which was exported just a few minutes ago. And now I also hear the remark that the load was imported from this project. If I would change the load in this original project, it will be also synchronized. And now I will just start this synchronize button. And now it automatically checks the differences between the original project in advanced steel and this latest design. So the connection is updating, and also the internal forces, if there is a change, are also modified. Yeah, so now we can check that now I have the thickness of this end plate 18 millimeters, and the bolts are now the 16. And as you see, I still have here that defined load, so I don't need to retype anything. And I just start the analysis again. So let's check it, whether it works or not. Perfect. Now it satisfies the check, and I can continue with another connection and so on. So that was that live example, and we can just finish the overview of the improvements in IDEA StatiCa Beam. We have also prepared new links, and we are releasing the link with Tekla Structure Designer and with the Revit. So now these latest versions of both these applications and IDEA StatiCa 9.1 are linked together with the same workflow as I demonstrated now. And now I will ask, please, to tell us more about IDEA StatiCa Connection Lite.
Thank you, Martin, for the presentation. Let's continue. Also, we want to talk about IDEA Connection Lite, which is our new product. Maybe some of you already know, but we didn't talk about it much. Now it's time to make it official. IDEA Connection Lite is a new tool available free online. It's a cloud light version of IDEA StatiCa Connection desktop, and you can access it easily via your browser at our homepage, ideastatica.com. We have a cloud tab, and here is online code check. Here you have several or dozens of possible connections with 2 codes, and it can be designed in hundreds of topologies. This tool is free, and we will be happy if you will use it. And also we have another cloud tool, we call it Viewer. This tool is also available at the same page that I already showed you, and it's designed for exploration and sharing of IDEA StatiCa project. You can send your project, for example, to your colleague, and he or she doesn't have the desktop version. Then he or she can open the project in the viewer, explore the entities, read all data or description, see the drawings, and even 3D DVG file can be exported and downloaded. So it's a really powerful new tool, and it's also for free. So we are almost at the end of our presentation, and we can read some questions, or I see that Adam and Martin already answered some of them. Maybe I can ask Martin, you can read some.
Yeah, I will check just maybe some of them. So the first question is about the BIM links, and the user asked us whether the links or the code check manager works for all BIMs links now in this way.
Thank you. This is a really nice question from one of our users or attendees. Yes, all this stuff that you see will or not will, it's now already prepared for you for all our BIM links, for finite element analysis tools and CAD tools also.
Perfect, thank you, Reed. And the second one is about the overload connection check, and user asks us again, what's the criterion for this check?
The criterion is 3 times maximum bearing capacity of the connected member.
Perfect. So I think that's all from these questions. Maybe if you have another one, we will ask them separately in the question chat, and at the end of this webinar. Okay.
Okay. So let's continue. Meanwhile, my colleagues will answer your question in chat. I will just do a small outro. After the webinar, as usually, we have a small survey. Please take your time and fill it, because it will help to improve webinars, especially for you, to the future. Recording of this webinar will be available within 3 days on our homepage or at our YouTube channel. Also, you can ask for the trial version at ideastatica.com, free trial. And please don't forget, we have our resource center, and you can find there updated documents, tutorials for connection design, tutorials for BIM links, frequently asked questions, theoretical background, everything is there. And you can also find our recorded webinars at our homepage. Our next webinar will be 2nd of May 2018. Oh, this is the old information. Sorry about that. And we will see you on Thursday, 11th at 9 o'clock, and also at 18 for concrete what's new in version 9.1 with Juraj and Lukáš. So this will be concrete webinar. Thank you very much for your attention today. I hope you enjoyed it, and see you next time.
Goodbye.